thank you to our glorious bronze sponsor, Aikido, for helping sponsor this conference. Thanks to, in general, all the sponsors, because we wouldn't have this great event and all these great presentations happening. So, without further ado, I'll hand it off to Ariel with her talk, Security by Designs, Lessons from Oracle Cloud Infrastructure.
Thank you. Hello, everyone. My name is Ariel Septon, and I'm a software engineer, and I lead our Oracle efforts at Native, formerly known as Rocksteady. At Native, we build multi-cloud security solutions for complex enterprise environments. But here's what makes us different. We focus on prevention. We know that cloud providers offer incredibly powerful preventive security features that no third party can match. After speaking with hundreds of customers, we decided to focus on these preventive security features, such as AWS SCPs, Azure policies, GCP org policies, and so on and so forth. We decided to focus on these preventive security features because while they are robust and well-designed, they require deep expertise in order to operate and configure effectively. And when it comes to multi-cloud setups, that complexity multiplies. As more of our customers begin migrating to Oracle Cloud, or in short, OCI, we decided to add support for OCI. That process, getting deep into Oracle's platform, taught us a lot about how OCI approaches security and exposed some meaningful differences in how it's designed. The truth is, most of our mental models are shaped by AWS, Azure, and GCP. These cloud providers dominate the industry. They headline the conference talks, fill the open source repositories, and they define what's considered normal in cloud security. So we expect familiar patterns: JSON policy syntax, familiar architectural concepts, and comparable security models. But what happens when one cloud provider doesn't follow those norms? That's exactly what we found out when integrating OCI. It made us question assumptions we didn't even realize we were making. And that is where the real learning happened. So let me be clear about what this talk is about and isn't. I'm not going to sell you OCI or tell you this is the best cloud ever, and this is definitely not a migration guide. We are going to discuss the different security design choices OCI made and what we can learn from them. And even if you never touch OCI, these lessons will make you better at securing any cloud. So what we're going to learn today. First, we're going to decode OCI's terminology, because every single cloud has its own language, and in order to learn from OCI, we have to understand its language first. Then we'll dive into 3 major lessons. Lesson number 1 is about policy syntax and how human-readable policies impact security. Lesson number 2 is about secure by default. And as an example, we're going to talk about encryption at rest and what happens when it's assumed and not optional. Then we'll dive into attack surface management. And eventually, I'm going to share the trade-offs. Because every single cloud has its own choices, and they all have different consequences, and OCI is no different. So let's start with OCI's model. First, you have the tenancy. The tenancy is your entire cloud boundary. Within that tenancy, you create compartments. You can think of compartments like a hybrid of OU's account, and AWS's OU's and account, or GCP's projects and folders. So these compartments in OCI could be nested up to 6 levels deep, and they contain the resources in OCI. In OCI, the policies are attached directly to the compartments or the tenancy itself. So just a disclaimer before I go into the policies. During this presentation, I am going to share with you guys a few policies, and they're going to be in the slides. But if I'm looking into my computer from now and then, it's simply because I just can't see that far. So how do IAM policies work in OCI? First, everything is denied by default. So without policies, you have 0 access to anything. Then permissions flow downward. So when you apply a simple policy at a certain level, those permissions are given everywhere below it. Now let's take a look at our policy statement. So here we have allow group DevOps to manage all resources in compartment production. And this is a real statement in OCI. We are going to discuss this syntax in the next slides. But for now, this is a real policy statement. And by applying this single policy statement, the DevOps team now have access to production, observers, databases, monitoring, front-end, and back-end, all by applying a single policy statement. Let's dive into lesson number 1, how human-readable policies impact security. So let's take a look at this AWS IAM policy. We have here multiple lines of JSON to only say one sentence. Allow reading and writing objects in my bucket, but only if they are encrypted. The problem here is that even if you are familiar with AWS's policy syntax, it might be a bit difficult for you to really understand the intent behind this policy. You can't just glance at that and understand if this policy is safe. In OCI, the same policy would look like this. Allow group DevOps to use objects in compartment production where target bucket name equals my bucket. If you can read English, you can understand this policy. OCI structures every policy statement the same way. Allow subject to verb, resource type, and location where conditions. Let's break it down. So subject is who gets the access, and it could be a specific group or any user. The verb is what they can do, and we are going to discuss those verbs in the next slides. Location is where this policy applies, so either a compartment or the tenancy, and conditions are optional filters. So let's talk about those verbs in OCI. In AWS, you have to know every single API action for every service. And when you are not familiar with them, it's pretty difficult to follow least privilege. But in OCI, those verbs are unified across every single service, which makes it very easy to grant least privilege because the verb tells you exactly what permission level you're granting. But why does all of that impact security? Well, with the JSON approach, you might find yourself questioning, wait, does this policy include delete object? But in OCI, read means read, which is crystal clear. So what we get here are a couple of things. First, we get faster reviews, because it takes us seconds versus minutes to understand a policy. Then we get fewer mistakes, because intent is very clear. And we also get here accessible security, because even people who are not security folks can understand those policies and use them. The principle here is if you can't explain a policy in one sentence, it's too complex. And complexity is where security vulnerabilities hide. The clearer a policy is, the less room there is for a dangerous misread. Let's move over to lesson number 2 that talks about security defaults and, as an example, encryption at rest. So look at AWS. In AWS, EBS volumes are not encrypted by default. If you create a volume and forget the encrypted flag, you get unencrypted data at rest. You have to remember to add the encrypted flag every single time. Azure is familiar. Without careful configuration, you end up with unencrypted disks. It's on you to remember, to configure, to verify, because the default path is the unsecured path. In OCI, you create a bucket, a volume, a database. It doesn't matter. It's always encrypted at rest. And there is no option to disable it. You literally cannot store unencrypted data at rest in OCI. You can bring this mindset to any cloud. In AWS, use SCP to deny unencrypted EBS volumes. In Azure, use Azure policies to deny unencrypted disks. By the way, make sure you do that for all the dozens of resource types you are using. The principle here is the secured path should be the only path. It's our responsibility to make sure we have secure defaults. So just remove the decision entirely and make the default path the secured path. Let's continue to lesson number 3, attack surface management. So I'm going to share with you guys a real documented attack pattern. This is published by MITRE ATT&CK, technique T1535 regarding unused regions. An attacker compromises cloud credentials. It could be either through phishing or a stolen end file. And then they map your attack surface. So according to their perspective, you might have 15 enabled regions, but only 3 of them are in use. Now I want to talk about those unused regions for a minute. If those regions are not in use, they are most likely to not be monitored as well. So no CloudTrail logs, no alerts, your security teams do not have visibility over those regions. So the attacker targets them. And then they deploy cryptocurrency mining in those unused regions. And again, because your security teams do not have visibility over them, discovery only happens at the end of the month when the bill arrives, and that is when you understand that you've been attacked. And this is exactly the region problem. Most clouds give you all regions enabled by default. In AWS, they historically auto-enabled all regions, but since 2019, new regions require opt-in. All pre-2019 regions are enabled by default. In Azure and GCP, all regions are accessible. But OCI flips this model. In OCI, when you create a tenancy, you get one region, which is your home region. And if you want to get access to a new region, you have to explicitly subscribe to it at the tenancy level. Once you do that, the entire tenancy gets access to the new region. You can block unwanted regions across clouds. In AWS, use SCPs, in Azure, use Azure policies, and in GCP, use org policies. Use them to block regions you never want to use. But OCI presents a unique challenge. Region subscriptions are permanent, so if you subscribe to a region, you cannot unsubscribe, ever. But what if you only needed that region in one compartment? Or maybe you just don't need it at all anymore. Let's see how we can disable a region we cannot unsubscribe from. So what we do is we use quota policies. And those are policies that operate independently of OCI's IAM policies. You can use the quota policies to set all resources quota to 0 in a region, and that way, even though it is technically subscribed, it is effectively disabled. The principle is disabled regions cannot be attacked, and every enabled region is an attack surface. So if you're not using it, you better just block them out. So if unused regions are attack surfaces, what about unused services? Think about it. Every single service you enable, you have to make sure it has secure defaults. And that's a lot of security overhead for services you're not even using. So it might be better to just block them out entirely. You can disable unused services across clouds. In AWS, use SCPs. In Azure, use the Azure policies. In GCP, org policies. In OCI, use quota policies. The principle of least functionality says only enable what you actively use. Everything else should be disabled or blocked. So if you don't need it, just turn it off. Now let's be honest about the trade-offs. Because every design choice has consequences, and OCI's choices create new challenges. Trade-off number 1 is about policy inheritance. So while we have here elegant simplicity, because one policy can affect the entire organization, this simplicity comes at a cost. Because if you apply a policy that is a bit dangerous at the tenancy level, the entire organization can be affected by it. Trade-off number 2 is about human readability. So I know anyone can read those policies, intent is very clear, reviews happen in seconds. However, OCI do not support complex conditions logic. So they just don't have this flexibility around conditions. So trade-off number 3 is about fixed verbs. OCI's fixed verbs create predictable permission boundaries. With that being said, the verbs are designed for common use cases and not surgical precision. So when you need granular control, it could be challenging to achieve. So how do we actually work around these trade-offs in practice? Our requirement is to only allow network admins to manage everything related to network. Let's assume our current state is that security admins, platform admins, and infra teams have access to manage all resources. Our desired state is that only network admins should be managed to use everything related to network. Now, we can't just remove those 3 statements entirely, because once we do that, all those groups will have 0 access to anything. So we have to find a way to create proper separation here. Let's see how we can do that. So, step number 1 is to create the dedicated network policies. So now, network admins have all their network privileges. However, we have to remember at this point that all the other groups with manage all resources still have access to network at this point. Which brings us to step number 2. We have to restrict security admins. We have to add at least 3 exclusions for network separation. Now, I'm saying at least here because this list of network services can grow. And the more it grows, the difficult it's going to be for us to maintain and manage it. Step number 3 is to now repeat for infra teams, platform admins, and basically, every single group who manage all resources needs these exclusions maintained. In AWS, I would automatically apply a deny SCP here. In OCI, I have to manage exclusions everywhere. And this is where OCI desperately needs deny policies, which they say are planned. We've seen OCI's strength throughout this presentation. Clear policies, semantic consistency, inheritance by design. However, this network separation scenario really shows us where OCI could improve. But we did learn something value here, that every design choice is a conscious trade-off. OCI chose readability over flexibility, security over complexity, security by default over optionality, and clear intent over technical power. What we learned here, that every benefit has a cost. Yes, we need more policies. Yes, we need creative workarounds, but security and usability can coexist. Let's wrap up with 4 universal lessons that apply to any cloud. In OCI, children inherit parents' policies, so structure compartments where parents have broader access than children. Make policies human-readable. Use clear naming, permission tiers. If a policy requires a paragraph to explain, it's too complex. Remove unsecured options. Do not rely on engineers remembering flags. Make the default path the secured path. And minimize your attack surface. Deny what you're not using. The real lesson from our OCI journey isn't about OCI. It's that security by design isn't about the platform you use. It's about making intentional choices. Choose clarity over convenience. Make your policies human-readable. Choose security over shortcuts. Make the default path the secured path. These principles work on any cloud. Thank you.
Thanks, Ariel. And yeah, like I said, if people have any questions, do please feel free to reach out and find Ariel afterwards. And yeah, another last round of applause.
Thank you.